All right, so let's start talking about the central nervous system. So, nerves are how the brain communicates with the rest of the body, and nerves are essentially bundles of fibers, bundles of axons, really. Um, and when we decide to move our hand to write something down, that message starts in the brain and it travels through the hand to make that movement happen. But information goes both ways. So, when we put our hand close to a flame, the sense of heat is transmitted back to the brain via nerves. And this helps to distinguish between the peripheral nervous system and the central nervous system. So the peripheral nervous system is involved with communicating signals from the periphery and back. So from like our extremities, our body, our trunk. And really, it's about sending sensory signals, collecting information for the brain. And it's also, the peripheral nervous system also communicates out motor signals, sending out actions from the brain. So those actions, though, are triggered by the central nervous system. The central nervous system includes the brain and the spinal cord, but we will take a hard look at the brain today. So, the basic function of the brain is to take in information and act on it. Make decisions, send information and commands back to the body tissues. It's a central command. Uh, some actions are really low level, really, really simple. And some actions are really complex, like reasoning and critical thinking. Low level functions are controlled by the older parts of the brain, so the brainstem and the cerebellum. So looking at this figure, you can see the brainstem and the cerebellum quite clearly. The cerebellum, actually, interestingly, cerebellum translates into little brain, because if you look at it, it's got these folds that are similar to the newer parts of the brain called the cortex. And so it looks like it's a little brain sitting below our big brain. So when we talk about the lower parts of the brain, it's both literal and figurative. So these are literally lower in the brain, and we're going to start actually with the very lowest part, the brainstem, which is continuous with the spinal cord. So you can see there that it goes up. So it's spinal cord, spinal cord, spinal cord. At some point, there's sort of a fuzzy division where it suddenly becomes the brainstem, and in particular, the medulla is that first section. Now, the brainstem is evolutionarily the oldest system. It's also, because it's old, it's going to be the simplest, most basic functions, right? You know, in order for us to be alive, we need a heartbeat, we need to breathe, we need some blood pressure. We need some really basic stuff to be happening. And so because this is the evolutionarily oldest part of the brain, it's also the part of the brain that's going to be doing all of that super basic stuff, all of the stuff that was our very basic building blocks for being alive. Um, so the brainstem is generally responsible for automatic survival functions like breathing, like heartbeat, like blood pressure. And it's also where contralateral organization starts. So contralateral organization refers to the fact that most nerves from one side of the body connect with the opposite side. You've probably, like, this might be on your radar. People like to talk about this, that the right side of the body controls, or sorry, the right side of the brain controls the left side of the body, and the right side of the brain the left side of the brain controls the right side of the body. And I like to mention it because it means that lefties are the only ones in their right mind. Yeah, that's a good one. I know it's a terrible joke, but so you get this crossover, and that crossover of nerve fibers actually happens in the brainstem. Now, part of the brainstem is the reticular formation. And so neurons that make up the reticular activating system, or the reticular formation, are really important for attention and arousal. In particular, they help to modulate sleep wake cycles. And damage to the reticular formation can actually really easily be fatal. Swelling might cause a lasting loss of consciousness, which is a coma, because the reticular activating system is actually necessary for maintaining consciousness. And so, yeah, yeah, like if you're feeling like a little dopey or a little sleepy or a little inattentive, that's definitely being controlled by the reticular activating system. Um, or the reticular activating system is at least playing a part in that. Next up, so at the very top, we've got the thalamus. And the thalamus is one of my favorite subcortical structures. So the thalamus is the sensory relay station. It receives both sensory and motor information from the spinal cord and brainstem, and then it acts as like a relay. So almost all, not quite all, but almost all of the sensory information coming in. So information from vision, touch, audition, gustation, all of them go through the thalamus before they get transferred to the cortical areas of the brain. So subcortically, this is the first place in the brain where sensory information is actually being processed, and it's every sensory modality except smell. And there's a very particular reason for that, but I'll talk about that in a minute. So incoming sensory signals are sent to the thalamus for like a really preliminary analysis. So they do get organized a little bit in the thalamus before being passed on to the cortex for more detailed analysis. And that's because the thalamus, or that's because the brainstem is where you put stuff that you want to happen really quickly. And so quick and dirty analysis of sensory information, really just to see, like, am I in any danger, or am I just watching an episode of Elementary? Is, that's sort of the level of analysis that's happening in the thalamus. It's really about like this basic level survival, and if everything is cool, then information gets passed on to the cortex for more detailed analysis. But the cortex is slow, so it gives you way more detail, but it takes way longer. So your brain actually really wants to be judicious about where it sends information initially. So the cerebellum so the cerebellum is involved with helping to smooth out actions, essentially. So the cerebellum compares action signals with the execution signals to make online corrections to voluntary movements, like walking or playing the piano or talking. Anything that requires a high degree of motor coordination is going to recruit the cerebellum. And so the cerebellum literally, the motor signal gets sent from the brain for our body to go do something. The cerebellum gets both that signal that's sent out, but then it also gets the information from the peripheral nervous system about whether or not that's happening. So it's comparing these two signals, and it's making any corrections if they're like maybe a little bit misaligned, and it does it again subcortically, so that the cortex doesn't need to be consulted, because that would take too long. So these online corrections happen super quickly and way outside of your conscious awareness. So your cerebellum is what's involved, when you're like walking. I do this on subway steps all the time because I'm not super familiar with subway stations. So if I'm coming out of a SkyTrain, I might be like checking my phone and then not realize how many steps there are. And so like the very last step, like I'm finished, but I haven't realized that. And so I go to take another step down, and then my body is like, oh, that's inappropriate for what's happening. It's my cerebellum that allows me to not fall on my face, essentially. Um, and uh, Interestingly, the cerebellum seems to play a role in verbal memory. Now, yeah, verbal memory is like literally memory for spoken information. And part of the explanation is that it's because, again, it's because of these fine motor corrections that the cerebellum is doing. One of the most complex motor actions we all do regularly is talk. You know how much fine motor coordination is happening right now? Are you super impressed with my talking? Um, that is in part because the cerebellum is helping to smooth out actions. And so it actually makes sense that fine motor movements in the mouth actually play a role in our ability to remember verbal information, because when we're trying to remember verbal information, we tend to um, do what's called subvocal articulation. So we kind of like say it in our brain, but we use all of our language structures to say it in our brain. And so the cerebellum still gets recruited, even if we're just saying it to ourselves. So I think that's pretty interesting. So the limbic system is a series of structures that rim the structure that helps to connect the two halves of the hemisphere. So it's this structure that sort of rims the inside of the brain, and limbic actually translates in Latin to the rim. So the rim system, the limbic system, and the limbic system is involved with processing anxiety, fear, emotions generally, and memory. Um, and it is also the sense most strongly tied to, it's also the system most strongly tied to olfaction. So you'll notice here this little sort of alien antenna coming out of the brain from the limbic system. And that little purple antenna that's sticking out is your olfactory bulb. So that's why the olfactory bulb skips the thalamus. It connects directly to the limbic system. And it's why when when you step out in the fall and you smell that first fresh smell of a fall, it might actually remind you of some really emotional memory, because it's tied to the limbic system, which is emotion and memory. Now, researchers were trying to figure out what it was that the limbic system actually does.